Hello, welcome to Unifying Branch and Campus Architectures with AOS 10 and AOS CX. My name is Clarence Hillard. I'm going to be your speaker today, and Yoni Osborne is also going to be co-speaking with me and speaking about some of the wireless end as well. On today's agenda, we're going to have a brief overview of the ESP architecture and the design and what it is to have ESP in your network at Aruba. Our wired design, so a little bit of the connectivity layer, which we're going to speak about. Network topology, layer 2 recommendations, layer 3 recommendations, and segmentation, when to use different segmentation stories or types, and why we should use those segmentation stories. Wireless design is where Yona's going to take over, and he's going to be speaking about instant gateway options, AOS 10, RF basics, and some wireless security as well. So first, a brief overview of the ESP architecture. So we have three silos or sections or layers that we want to speak about: unified infrastructure, zero trust security, and AI ops. So the first one I want to speak about is unified infrastructure. Unified infrastructure is this idea of having the similar product set across verticals, right? So no matter if you're in the campus, the branch, remote, data center, you're going to still consistently use AOCX or AOS 10, et cetera, right? You're not going to have a different particular product set for campus, a different product set for data center, a different product set for branch. It's all the same product set, so you get basically the same user experience. The reason I say basically the same is because you're obviously going to be configuring different options depending if you're on the data center, the campus, branch, et cetera. So basically the same experience because you're just going to have the same operating system. So you're going to be familiar with that across the entire portfolio. Zero trust security. This is the idea of removing the IP address from the security policy, right? So now we're going to apply policy based on your role and who you are on the network. So when you come onto the network, we want to identify you, give you access to what you need to do, and then apply policy based on who you are, not based on your IP or your location. AI ops is machine learning, right? Artificial intelligence, and everything that is that. It's a very large conversation when you get into that. But that AI ops in a nutshell is really just machine learning and making that user experience better for the user without them even needing to be aware of what's going on. And also for the admin to make his job easier as well without needing to know all the nitty-gritty details of everything that happens on the network. And a lot of that's going to take place in Aruba Central, which is our management platform. So moving in to another layer deeper, the connectivity layer, right? Unified infrastructure. This is, again, our gateways, APs, switches as well. Now, in this particular presentation, we're going to be speaking mainly about AOS CX, but a lot of the core capabilities and mentalities that we have apply to AOS switch as well. So you'll see 63, 83, and then also you'll see 2930, 3800 in this presentation as well. Policy. So there's two sections to policy. So management, clear pass and central. And this is where you're going to be defining your policy and pushing your configuration. What roles am I going to have on my network? How do I want them to be applied? What particular devices do I want to have those roles? Your enforcement is going to be on your gateways, switches, and APs, right? Because you want to actually have those policies that you have defined via central clear pass now block on your switches and APs and gateways. You don't want it to traverse the entire network and then find out it's been blocked, right? So you want it to be blocked as close as possible. So that's your policy layer or zero trust security. Then we have services. So within Central, we have many services. CPDI, so Clear Pass Device Insights. This gives you visibility and deep packet inspection as well on devices. Then we have UXI, which is network assurance, right? So you can have a sensor on your network that will give the sensor the same user experience as a client, right? Or a user, someone on your network already. And that way you can actually see what they're experiencing at that in real time. So if they're complaining about an issue or they have an issue or something's going on, you can actually get that data from the client's perspective as well, rather than saying, well, I don't have any data to go back on, or we're gonna have to wait for this particular problem to come back up again for me to be able to troubleshoot it. So very, very good, handy tool. Then Meridian, so location services, analytics, and all that fun stuff. So multiple services that fit within the bucket of Central, and tons of capabilities that we have here. Now, for this particular presentation, we're really going to be focusing on our policy and connectivity layer. Right? Services are you really just turn them on and you're just going to be using them, right? So there's not much from a design perspective for you to really need there, other than, hey, turn it on, you can use these things. But policy and connectivity, those are two things that we're going to be speaking about in depth. So first off, the campus wired design. So before I go into the nitty-gritty details of the wired design, I wanted to set some design goals. So we want all the modules within our network to be easily replicable, and we want it to scale as the network grows. We also want modules within the architecture to have minimum impact to other layers and within the same layer as well. And we want to provide small fault domains to improve resiliency within the network. So what does that mean? If we move to the next, or this slide here on the right-hand side, you can actually see that we have a typical three-tier architecture. So at the very bottom, you can see there's a stack of switches. Then in the middle, there's an aggregation layer. And we're going to speak about this in the next slide a little bit more in depth. But when I say we want to be able to remove and add things within that particular layer, the aggregation switch, if it goes down, we don't want it to take the entire network down. If the one core switch goes down, we want it to take the entire core network down. If a link goes down, we don't want it to take it down the entire network, and vice versa. Now, obviously, if you remove your aggregation switches, the network, your access switches aren't going to have any connectivity, so the network's going to go down. But that's what we're really talking about when we're saying, hey, modules can be added and removed and won't impact other layers as well. So I jumped ahead a little bit in that slide where you got a brief overview of a three-tier architecture. I think the key thing to note is when you should be using a three-tier architecture and a two-tier architecture. A three-tier architecture is typically used for large companies, but the main constraint for it is really your physical layout. And so a smaller company can use a three-tier architecture as well. The reason it would be more of a physical layout problem is because once you get past 3 buildings, is what I like to say, that's when cabling can get messy and scalability starts becoming a problem. This can be a factor in that as well. But mainly it's that physical layout of being able to interconnect and have redundancy between buildings. Once you get past 3, it gets really, really messy and you have to start pulling a lot of cable to multiple buildings just to have redundancy. And having a 3-tier architecture allows you to just pull to your core and then you're done. Your core switch will be able to handle the connectivity to any other device within your network. Nodes. So at the very, very bottom, I say 1,000 to 10,000 nodes on my 3-tier network architecture. That's just a typical number where we typically see customers lean towards going towards a 3-tier architecture. It's not really a scalability thing. It's really just, hey, once you have 1,000 nodes on your network, typically you're at 2 or 3 buildings anyways. So you probably want to start thinking about moving to a 3-tier architecture. Now on the right-hand side, we have the 2-tier architecture. This is really typical for mid-sized companies. So you have one building, you have a combination of suites, maybe it's a bunch of small offices, maybe it's a warehouse. In this situation, you don't have a core network. We have what we call a collapse core, where it is the layer 2 boundary and layer 3 boundary, and it connects all your access switches into that collapse core. So the only time you're going to use this is really when you have suites, small offices. And again, this node's at the very bottom, 200 to 1,000, right? Once you start getting up to 1,000, a lot of the time companies move to having more than one building. So that's when they start thinking about, hey, maybe I should transition to a 3-tier architecture versus having my 2-tier. So here we have the actual in-depth information around that 2-tier design. All right, so again, we have our collapse core, which is going to be a dual switch VSX. So in the middle here, you see collapse core, and then you see a little gray outline around that collapse core. That insinuates that there is a VSX configuration between those 2 devices. Now, the reason we do that is really for our access switches. I'm going to jump down a little bit here to provide redundancy for our access switches. So LACP, VSX Live upgrades, etc. There are lots of features and functionalities. We're probably going to talk about a little bit of them later on in the slide deck. But that's the main reason that we have that there. And it's just going to provide layer 2 redundancy, and it's very, very good for you. You'll see on the axis on the slide, I have L2/L3 axis. Now, for a majority of customers, L2 is probably the best way to go, especially in combination with VSX, because that eliminates spanning tree. But the main reason you want to go with L2 is for roaming, right? So if you're running IAPs, you don't have to really worry about roaming because they're all in the same L2 stretch domain. so you don't have to worry about too much of that. If you are going to go L3, that's why you would need a mobility gateway. So back up at the top here, you'll see I have the collapse core, and then I have mobility gateways. That's the reason there's an extra asterisk there. The reason for that is because if I'm running L3 down to my edge and I'm running a two-tier architecture, I'm going to want to design my network for roaming to be great for me. And that's the only time I'm really going to have a mobility gateway is if I'm doing L3 down to the access. So it's just, there's no bad way. It's just a personal preference for most customers if they want to do L3 access or L2. But I would recommend L2 just because it simplifies your roaming and it saves you a little bit of money on controllers as well. The next three features of your collapse core is your WAN aggregation, internet firewalls, and your organization's servers. Right, so all three of these things are going to be connected into that collapse core, as well as your access switches, which is going to just provide connectivity for your access clients. Right? And that's the reason we call it collapse core, is because all services, everything is connected into that core. And then to route out to the internet, you're going to need a static route. So here we have a three-tier architecture. We gave you a couple of previews of this earlier. This particular three-tier architecture has a core and services combined. And so in that last slide, we saw that my aggregation layer, my access aggregation that you have in this slide, was combined with my core and services, which is the collapse core. So all those features connected together. In this design, I've now separated my routed infrastructure and my services, and they're combined together. And so I'm still going to have that dual VSX capability. I'm still going to need in this case, I'm going to need a mobility gateway because I'm separated by an L3 boundary between my access aggregation and my core and services. And I'm going to have my WAN aggregation, my internet firewall organization servers there as well. All right. So I want to take 1 second and just expand upon that point of the gateway actually being connected to my core services and needing a gateway in this scenario. In the last scenario, everything was L2 adjacent. In this scenario, everything is not. Between buildings is not L2 adjacent. So from access aggregation on the left-hand side to access aggregation on the right-hand side, we're not L2 adjacent. So if I'm roaming between those two buildings, I'm going to have a bad time, right? It's not going to be a very smooth transition. Or if I'm roaming within the same building as well, I'm not going to have a very smooth transition. So to optimize that, we pull everything back to the gateways, and that's why you would need a gateway within this particular architecture versus that collapse core. Again, at our access aggregation, we're going to be doing a combination of L2 and L3, right? So we're going to do VSX between my two access aggregation switches, and we're going to be routing upwards to my core and services, right? So running OSPF. And then we're going to do MC lag down to the access, which is same to the last slide. I just didn't add that bullet point in there, but it's going to be an M lag. So those devices in the VSX pair appears the same single device. Then at the very, very bottom here, we have our access devices, and same thing, right? You're just providing access client to clients that are connecting in, and then you have LACP running up, and you have your redundancy there, right? And this eliminates spanning tree and all that good stuff as well. So there's one more three-tier architecture here. And in this situation, everything is basically the same except for your service aggregation. So this service aggregation is now abstracting the services and core functionality into two different sections, right? So before I have my services and my core combined, this situation, I have my services in another aggregation block. And the main reason we do this is for scale, right? If I have a bunch of APs or a bunch of devices being tunneled to a controller, I'm going to be dumping a bunch of MAC addresses, ARP entries, etc., into my core, as well as having a ton of route entries on my core. So I'm going to be eating up a lot of table space. So the main reason for this is just to scale everything up, right? So now I can actually keep my core just as a routing function, and its sole purpose is just to connect buildings in together. It's all it's going to be doing from this point on. Your service aggregation is now where you're going to terminate all those services again. So your mobility gateway, your servers, your WAN aggregation, all that good stuff. It's going to be terminated there. So that's everything about the actual physical layout of the network. I did want to take a step. I didn't want to put a one transition slide in here just to talk about some of this because it's relatively simple features, but I feel like it gets overlooked quite a bit. And We're going to be transitioning into a lot of features and functionalities right now. But before I do that, I wanted to just talk about the base configuration that we have on the network. Right, so host naming convention is always something to just remind you, hey, you need to have a naming convention for your network, something that your organization could follow. Your message of the day, DNS name, not just having a DNS name on your switch, but pointing to the correct internal DNS servers. NTP time zone, we recommend using UTC. So if you are a multi-international or a very large organization that might have that problem, you can at least keep your logs consistent across the entire infrastructure. You're going to want to have logging on. A lot of customers are using SMP. Obviously, with Central, we can monitor and manage a lot of that. SFlow, right? These are all third-party tools that customers are typically use and have installed. Network Analytics Engine, I just wanted to briefly mention that there are 3 scripts that you should probably take a look at. The hardware device monitor, the software device monitor, and the application health monitor. The hardware device monitor, it runs on the switch and it just ensures that fans, CPU, heat, temperature, all that type of stuff is running okay. The software device monitor is making sure that your processes on the switch that are running smoothly as well. So 2 very good NAE scripts to run to just ensure that your network infrastructure is safe and secure. Now you have the application health monitor, which works hand in hand with the IPSLA feature on the switch. And this will allow you to actually monitor particular applications and see the service level on your network and see if they're good or bad. So there are 3 scripts I'd recommend checking out on CX devices. Obviously, AO switch doesn't have this. TACX and local accounts. So you're definitely going to want to have TACX implemented, and you're probably, if you're a large organization, that's going to be the main way you want to have everybody access devices for continuity and accountability across your network. And then you're also going to have local accounts as well. So local accounts is just for a backup in case TACX server goes down or something bad happens. You need to get in via the CLI. You don't want to have solely TACX access for your network devices. And API access is the next thing. You want to ensure that that is secure, and it does need to be enabled for things like NetEdit, etc. If you're doing any type of automation. So it's always something to just be aware of. If you're using it, keep it on and ensure that it's secure and you have the correct TACX accounts and logins to get into the switches to use those. But if you're not using it, obviously you just turn it off. Rather be safe than sorry and let somebody attempt to get in through that particular mechanism. So the first thing we're going to talk about is layer 2 type technologies, VSX, stacking, and VSF. So VSF is our front plane stacking mechanism. So it's very, very similar to just normal stacking, except we do it on the front ports. We recommend you using a ring topology for this, and then as well as a sequential numbering across your devices. The difference between VSF and VSX, as I transition into what it does, is that VSF combines the control plane, management plane, routing plane, everything. So once you VSF or stack the device, everything is combined. So if you have one IP address that you manage that particular box on, or set of boxes on, that's going to be the IP address that you use to manage that box. Now on the flip side, on the bottom here, VSX does not combine the management plane, the control plane, and the routing plane. Right? All it does is it makes it so LAC ports appear as a single device from the access device's perspective. In this picture here, this access device on the VSX side is actually showing you that that access switch is lagged to 2 separate switches, and it thinks that those 2 separate switches are the same switch. It doesn't know. This also gives you the ability to have an active-active gateway, right? Without a first hop redundancy protocol like HSRP or VRRP. So if one of those switches goes down, it's immediately going to go to the other switch with minimal downtime, right? And this gives us the flexibility for something that we call live upgrades, right? So we can actually turn off one of the switches, upgrade it, and boot it. And then while that switch is up, going down, booting, and upgrading, the other switch is taking over all forwarding paths right now at that point in time. And then that switch will go down and it'll upgrade and reboot. Right? So very, very handy, very good to have enabled and used on your network. So next up is spanning tree, one of the most hated things in the industry. Even though we're using VSX with MC lags going down to our access switches, we do recommend that you enable spanning tree as a just in case mechanism, right? I'd rather have it on and be safe than sorry, just in case someone plugs in a particular access switch and it has spanning tree on, it's not running LACP. You don't want it to create loops on your network. So where we recommend you enable spanning tree is on your access aggregation switches. They should be your root bridges. So that means they're going to have the lower bridge ID, and you want them to be set per aggregation switch. So your service aggregation, your access aggregation, every single device, every single aggregation pair is going to be a root bridge. And the reason you can do that is because they're separated by L3 boundaries, which is your core. Right? The core of your switch, your core switch is going to be routing, so no BPDUs are going to be, there's no loops that can happen there. So you can leave that at its defaults and not enable spanning tree at all. You want your high bridge IDs to be any access switches, controllers, or gateways, anything along those lines. You want those to be high bridge IDs because you don't want them to become the root of your topology at all. Okay, so relatively straightforward there. One thing I do want to add here is in using VSX, there's a feature called LACP fallback. So in that scenario that I just drew out of somebody plugging in an access switch into your two aggregation devices, you're probably going to want LACP fallback enabled as well, which is in the slides. And the reason for that is it's actually going to disable one of the VSX links, the MC lags, and allow traffic to go up another link. And that allows for you to do things like ZTP, etc. And spanning tree, with that enabled on that bottom access switch, it's going to just do its own thing and realize that that's the only path that's available to it. So just a key tip on that as well. So there are a lot of supplemental features to spanning tree. So root guard, admin edge, BPU guard, loop protect, BPU filter, and then the fault monitor. So root guard, you're going to want to have this enabled on your aggregation or collapse core switches. The reason for this is it prevents any access switch from taking over root on your network, right? And you really want that protection, so nothing else becomes root on your network. Or if something does try to, it's going to shut down those links, and that device won't be able to join or get any connectivity until it gives up that root level priority. And then you have your admin edge, and this is on your access switches specifically. You're going to want to enable that just so ports can get enabled really quickly without having to go through the STP listening learning phases as well. BPDU guard, this automatically blocks BPDUs from being sent on a particular interface. You're going to want this enabled on your access switches, so the downlinks facing the clients as well. So admin edge, BPU guard, both are going to be enabled on those downlinks. In addition to that, you're going to also want to enable loop protect. Right? So these three features, admin edge, BPU guard, and loop protect, you're going to want to be enabled on the downlinks of your access switches, so the client-facing ports. Now, loop protect is also going to protect you from loops as well, and it's going to automatically detect and unblock things. So if somebody does plug in something and it creates a loop, it'll block that particular port. If something plugs in and it's sending BPDUs, it's going to also block that port as well. So this just gives you that control over your network to say, hey, I don't want certain things to be plugged in and creating loops on my network within an access switch at all. And then BPU filter, this one I wouldn't recommend unless you have a very specific use case. So what this does is it ignores any BPDU that is coming through an interface, right? And what that means is you can potentially create loops in a nutshell. So if you don't have a really good reason to use this, I wouldn't recommend turning this on. The only time you would use this is, let's say we are running, for whatever reason, we had our access aggregation switches in that last slide, and we have our service aggregation switches as well. Let me actually go back to that slide for you. So if our access aggregation switches and we have our service aggregation switches, and we have our core in the middle here. And for whatever reason, we wanted our service aggregation and our access aggregation switches to participate in the same spanning tree instance, we would turn BPU filter on the core switch, and then it wouldn't participate in spanning tree at all. So it wouldn't decide, what's going to be my root bridge or what's going to be my root port or any of that stuff. It's just going to forward the BPUs, and that would probably be the only time you would need that. You probably wouldn't need that, but that's the scenario that you would use it. So I wouldn't recommend you using it unless you have a very specific scenario that you need to use BPU filter like that. And then lastly, the fault monitor. This automatically detects excessive traffic on particular links, and it's used this in logs and SNMP traps and all types of things to like a server, and it'll also automatically disable a port for you if there's creating loops or anything like that. So very, very good to enable and utilize that feature, and this would be obviously on access switches as well. So the next thing is QoS. So when thinking about QoS, we can get very, very deep very quickly. So I want to give some relatively high level guidelines on QoS. So first thing you want to do whenever you're deciding your QoS policy on your network is identify what real-time applications and business critical applications you have in your network. Right? All your real-time applications are going to have to be placed in a strict priority queue or EF, expedited forwarding. And then anything else that's just more business premium, like let's say Office 365 or something along those lines, you're going to want to place in a premium queue. So things that your business needs to run, but it isn't as high of a priority as real-time applications. Then everything else will remain in the best effort queue, right? Any other remaining business applications will be best effort queue. And then you can actually optimize your traffic on that, right? I think the one key thing I want to note here is if it's possible, try to mark it at L3 rather than L2. The main reason for this is because QoS doesn't even get enabled at all. It won't trigger. So you could set up all your policy. It won't trigger unless your network is congested. It's the only time your QoS policy is going to be congested. And it's very unlikely that your L2 domain is going to be super congested, right? Whether that's from your access to your aggregation or just in that access closet if you're running L3 down to your access. It's very unlikely, but you can enable it. If you are going to do that, you're going to have to do some classes service consolidation to your QoS mapping as well. So just to be consistent across your network. I did note this on the slide, the classes that you have, the low drop priority and all that fun stuff, just so it's on the slide, just for your own information that you have this and for reference. But for here, what we're going to be using is all your a mapping of what I was just saying in that slide. So your real-time interactive protocols, right? We're going to be expedited forwarding, so 46E. And then again, we have the AF31, which is best effort, and low drop priority, which was in that slide before as well, is what you're going to want to put there. And then bulk data is also going to be put in AF21. Right? So these are the different QoS policies, and again, it's just typical. Anything with the AF is really used by you, like you set your own policies. This is what you want to be placed in there. So this is our recommendation. You can obviously use these slightly different, or you can use different priorities for different things. You can always add more or less if you want to. But the main reason for using this is for a for queuing mechanism, so you can have that done on your devices as well, and have it consistent across other for queue mechanisms as well. Routing technologies. So I've hinted at this a couple of times, but just to reiterate, whenever we have a three-tier architecture, anytime we're going across to our core, we're going to be running OSPF. So in this three-tier architecture, with my service aggregation separated, I'm going to be routing from my core to my service aggregation, and I'm going to be routing from my core to my access aggregation as well. And if I just had my core and services, even if it was combined, I would be routing between my access aggregation and my core as well. Whenever we're using OSPF within the campus, we're always going to be using area 0 for the entire campus. We're going to also ensure that OSPF passive interface default is going to be enabled on all interface VLANs on my access aggregation switches, which means I just don't want my access aggregation switches to negotiate OSPF handshakes with anything on those VLANs, right? I just want to advertise those VLANs out. And then we're always going to use a loopback IP address for our router IDs as well. And this is for lots of things like multicast and whenever we want to terminate anything, and just to ensure that we have a loopback address that's reachable as well on the network. Default gateways for my L2 switches, they're always going to point to the active gateway on my VSX pair. So this is that active forwarding IP address that we have in VSX. And so that's what we're going to want to point to for those. And then for my static routes for the internet, I'm just going to have a static route that's on my access aggregation devices for anything I don't know about within the network. Okay, so multicast. So now that we have OSPF enabled, we can also enable multicast. And there's a couple of things we want to note about multicast. So first thing first, we're going to be using PIM sparse mode. And this is because we want to optimize reverse path forwarding. We don't want to use PIM dense mode because it's a flood and learn mechanism. We don't want to do that. The next thing is on our core switches, we're going to enable 3 protocols. So BSR, RP candidates, and MSDP. So these 3 features work hand in hand. BSR, its functionality is just to advertise what device is the RP on the network. Right? That's all it does. And then within BSR, you have the RP candidate, and that RP candidate is also is going to say who has a priority and linked to be that particular device that's going to split the multicast tree. Now, if you're using MSDP, what this gives us is the ability to load share between devices. Right? So I can actually I can have more than one RP on my network, where if I was just to use BSR and an RP candidate, I would have only one RP for my entire network. But if I use MSDP, I can have more than one, right? And not only can I have more than one, I can actually load share between those devices by using the same Anycast IP address on those devices. So it's very, very handy to use. And we highly recommend you use that if you're enabling multicast on your network. That way you can have redundancy between your devices and you get load sharing as well. So you get the best of both worlds, and you can also lighten the load on one of your core switches as well. And then IGMP, you're going to want to enable IGMP on your access aggregation switches, as well as IMGP snooping as well. And you're going to want to enable IGMP on your access switches also. And I don't think Yona's going to actually talk about the multicast enabling in his particular section, but you can enable that on you're going to want to enable dynamic multicast optimization on your wireless APs. And then it's just going to, basically once it's enabled, it's going to use the multicast infrastructure of the switching infrastructure to forward that on. So you'll be good to go. So you just want to make sure that's enabled and you're good to go. So I wanted to also show what it would be like to enable multicast on a 2-tier architecture as well. So here, again, you're not going to need PIM-SM unless you're routing between anything. Again, that's if you have L2/L3 access. Again, we don't really recommend it, but I put it in the slide just so you have the continuity if you are going to be using L3 to the access in a 2-tier architecture. BSR is going to be on your collapse core again. Your RP candidate is also going to be on your collapse core, and your RP is going to be both devices. And that both of those devices are going to be using a loopback address, right? An Anycast loopback address, just like before. And that Anycast loopback address is going to be what's used for MSDP to give you that load sharing between your devices, right? So you're going to have that all configured on your collapse core. And then IGMP snooping is also going to be running on that collapse core, and it's going to be running on your access. So a little bit more complicated there again. But you're just combining a lot of those services into your collapse core like we did before. So the next thing we're going to be moving on to is network segmentation. So the first network segmentation technology we have is user-based tunneling. User-based tunneling gives you the ability to turn your switches into APs. And what I mean by that is you can actually pull back anything that's connected into your switch and terminate that at a mobility gateway. Now, this gives you a few benefits, right? So you can actually centralize your VLANs. You also now have the ability to apply policy based on role, and you have the continuity between wired and wireless. So the main reason you want to use this is for a microsegmentation functionality. That's the main advantage to this, because now I'm obfuscating the idea of the VLAN IP, and I can actually apply a role, whether you're on wired or wireless, and I can apply a policy to you, and between wired and wireless as well. So if you're going to use this, for example, let's say in this example, I have my guest, my employee, and my IoT devices as well. I can have those 3 roles pulled back to my mobility gateway, and I can have a policy that says my IoT devices can't connect into my employee devices, right? And vice versa. I can deny those two roles, even if they're within the same VLAN. And I can do that for anything, right? So that's the main advantage using user-based tunneling. In addition to that, no matter where you go on the network, say you're an employee and you plug into switch one in building one, and you go to building two and you plug into switch three, you're going to have the same role no matter where you are within the network. Additionally, we have a feature called port-based tunneling, and this is only on AOS switch devices, where we will consistently tunnel you back to the controller for one or two particular VLANs. Let's say I have VLAN 10. VLAN 10 is always going to be tunneled back to the controller no matter what, in a nutshell. And this also gives me that same ability to be able to apply policy based on role, right? So I can always apply my policy based on whatever role I have on the network. So there are a lot of advantages to that. Just to summarize, role-based policy, that's the big advantage here. It's very flexible underlay. So if you're using L2, L3, doesn't matter. As long as we can get to the controller, we can apply the policy and we can do this architecture. Very, very simple to set up and very easy to do as well. And if you don't want to tunnel everything back to your mobility gateway, you can just use the underlay as well. So not everything has to go back. And this is all defined by ClearPass, right? So my user role is going to be applied to me based on my authentication. So if I get authenticated and ClearPass says, hey, I want to go here, or hey, you're going to be just plopped into VLAN 10, and the VLAN 10 is just normal L2 adjacent to my access aggregation, we can do that as well. And let's say another device, my IoT device, needs to be tunneled back. I can, once I have authenticated, that device can be tunneled back as well. So it's very, very flexible in that sense as well. So very, very advantageous to use. And again, the main reason to use this is for microsegmentation. And the next one is virtual network-based tunneling. So virtual network-based tunneling is a VXLAN, BGP, EVPN, and being able to extend L2 adjacent devices, right? So if I want to extend my L2 domain, I can do that. So if I want to extend my employee VLAN across multiple buildings and have the same subnet across multiple buildings, I can do that, right? I can also integrate this because it's standards-based BGP EVPN with something like a Palo Alto firewall. I can terminate my VXLAN tunnels at a Palo Alto firewall, so I can apply policy there if I wanted to, if I wanted to, or I could apply it at any other device that I want to terminate my VXLAN tunnel to. So it's very, very flexible in that sense, in the sense that it's open standards-based. In addition to that, if I wanted to do some even more level of segmentation with this, I could terminate my VXLAN tunnel to, let's say, my service aggregation in a separate VRF and completely separate out one network from another network if I wanted to. So very, very powerful. And the main reason you're going to use this is really for that consistent VLAN scheme across multiple buildings if you want to have that. In addition to that, you might also want to have a macro segmentation for your devices, right? So that's really what we're going to be doing with VXLAN BGP VPN is it's macro segmentation, right? So it's really just VLANs, but VLANs extended. So if you are doing IP-based protocol or IP ACLs, etc., you can still do that here. It's just that this extends across multiple devices now or multiple buildings. And if you want to use this in combination with user-based tunneling, you can absolutely do that. So if you have the use case of you need to extend your VLANs across multiple buildings, but certain devices you want to terminate back at your mobility gateway, you can do that. And that gives you the best of both worlds, where you can have the macro and micro segmentation all at the same time. It's just a matter of you turning it on. Now, the way you would do this is very similar to what I was speaking about before, where ClearPass would drop you into VLAN 10, for example, and VLAN 10 might be a VXLAN tunnel, right? And that VXLAN tunnel is going to traverse across the network, and you're just dropped into that VLAN as a user, and you don't really know the difference. Where you can also be dropped into a particular user role, and that user role is going to signify that, hey, you're in a port-based tunnel, and now you can get tunneled back to your mobility gateway, and you can even get tunneled back to your mobility gateway and then popped into another VXLAN tunnel if you needed to do that as well. So very, very flexible, and there's a lot of options if you start to combine the two technologies at the same time. But the key thing to note is user-based tunneling, port-based tunneling, micro-segmentation, VXLAN, macro segmentation. And the last thing to note here is your VLAN size and subnet size. You, even though you have these technologies where you can stretch and terminate things, you don't want to create too big of a VXLAN domain, right? Or a user-based tunneling domain as well. You still want to keep those things relatively small. So when using VXLAN, you still want to keep it around /24/20, right? You don't want to have any of that, a very, very large broadcast domain, because that's going to be spread out to multiple devices. And there's obviously some suppression and stuff that goes on, but in general, it's just not a good habit to just extend it out to like a /16 or something like that. It can get really, really bad and hard on those devices as well. And you'll start seeing some performance errors as well. On the wireless side, /18, 16,000 hosts. So even if you're going to combine user-based tunneling and you're going to pull things back, don't make your subnets in super, super large, right? You want to keep them relatively small and manageable. So with that being said, that's everything on the wired switching design. And I'm going to transition over to Yona. Yona's going to take over and speak about the wireless design on AOS10 and all that good stuff.
All right, Clarence, thank you. I will continue with wireless design and what we can do to make sure you're getting the best possible experience with your wireless network. A couple of design goals is to make sure we're getting a simple, scalable, and repeatable network that can be used for your every building, every floor, every branch, and all over your enterprise. It should be flexible to scale based on your sizes, and also it should be optimized for good performance and good reliability for all the different use cases and the user capacity for the individual buildings or areas. When you're doing your design of your wireless network, it is important to think about what is the need and what kind of building do you have. What is the density of people you have? One of the things you have to think of, the density of people in a theater or a student dorm or a student classroom in a university or in a waiting room in an office or a medical place. All those different scenarios have different need and different density of people. If you think of normal traditional office space, normally we would have between 150 to 200 square feet per access point per user, and normally we'll have 1600 to 2500 square feet per access point. You might have some areas of the building that have higher density, like cafeteria, and then you need to plan your deployment in that area based on the specific need in that area. You might also have some areas where you have high density of devices. That might be a training room where you will have people bring both their mobile device like a laptop and mobile devices like their cell phone and other devices. And besides that, we need to think about long-term. What is your long-term goal with this building, with this network? Plan for how this will be for 3 to 5 years. Because one of the most expensive parts when you're deploying a network is actually the labor and the cabling cost, not the access point itself. So with all these things in mind, that will give us some ideas on which direction to go. We're going to dive deeper in and look at the different options we have with Aruba, how we can choose to use on-prem or cloud-based management. Some businesses are very pro cloud, while other enterprises want to run everything on-prem. We also have different generations of our architecture with our AOS 8 based portfolio and our next generation AOS 10 based portfolio. So if we start looking at our on-prem managed portfolio, you can either use instant access point that are scalable up to 128 access points, or you can go with our AOS 8 controller-based architecture. If you're going with instant, it's running without the controller, but one of the APs in the architecture will function as a virtual controller in that cluster. One of the major differences with this is the instant will have the same, will need to have the same VLAN on all the switches you have. So we're local bridging the wireless traffic onto local switch and following the upstream routing on your network. If you're going with the AOS 8, there's a controller included in this. We are scalable to up to 10,000 access points in the solution, under one mobility master. And besides that, you're getting functionality like clusters, live upgrade. So you basically at the 5.9 uptime with this. You will even be able to do upgrade without having downtime for your users. And to be able to make this scalable, we have hierarchical configuration, which makes this very easy to manage. For those that would like to go into cloud, we have two different approaches here as well. You can do cloud-based management using our instant access point with software version 8. That is the software version that has been out for several years and have been reliable for a long time. You're managing from central, but most of the processes are being processed on the access point itself. We're still limited to the scalability of 128 APs per cluster, but we have the ability to have distributed locations and have multiple locations with identical configuration. Examples can be fast food chains, where you might have tens of thousands of locations, but all of them will be the same. We will have way less than 128 AP per location, but we can have thousands of locations. That's one of the perfect examples of Central's use case. We also have the ability to enable Cloud Guest when you're using Instant and Central. That means you are using our central architecture as the guest management portal instead of using the built-in Captive Portal architecture. The next architecture we have is our AOS 10, the next generation architecture, still managed by Central in the cloud, and we're scalable to 10,000 access points for one campus. This is a major scalability enhancement compared to what we have had before, and we're also adding a lot of new enhanced features into this. We'll come back to some of the new features we have here. We're still able to use one dashboard where you're managing everything from your small branch, your SD-WAN, your large enterprise campus, your remote access for home users, your remote access for VPN. All of it will be managed from one common management platform. So let's look into our Instant version 8 architecture a little bit more. Like I mentioned, Instant version 8 is requiring that the APs have the same VLANs on all the switches. So when employee in this scenario is connected to one AP, and if that should be on VLAN number 10, if that employee is roaming to AP number 2, the VLAN number 10 needs to be available on that AP and that switch as well. The different APs will handle roaming between themselves and handling key exchange to make sure that the roaming is as good as possible. One of the APs in the architecture will own the role as a virtual controller. That AP will also then handle radius requests. So it will work as a radius proxy to make sure that the radius request going to your ClearPass or the radius server will always come from the same source IP address. And if you're going to do change of authorization, COA, that will also be sent back to that virtual controller that will know which AP that specific user is connected to. For those that are scaling more than 128 APs, that might be that you have 128 APs on each floor in the building. We can do extension to layer 3 roaming between different clusters, but it's recommended to limit that kind of use. You will automatically then get into challenges with roaming that makes the roaming not as optimal as it would be if you're going with a controller-based architecture. If you're going any scale over 50 APs, we recommend that you are working with our professional service. They will help you make sure that your solution is working as expected and you're getting the best out of your wireless architecture. Our other on-prem based solution is to use Aruba OS 8 with controller-based networking. You can run your AOS 8 architecture with one standalone controller if you want. That controller can scale from the smallest one with 16 access point support up to the largest one with more than 2,000 access points on one standalone controller. To make this more scalable and get the best out of our controller-based architecture, I would recommend using our mobility conductor. With the mobility conductor running on VM, we're taking advantage of the optimal performance that we're getting on VM architecture and CPU power that are in VM architecture, while we're using the optimal performance on network data path traffic on our mobility controllers. So the mobility controllers will then not spend energy on doing management frames. They're using all their CPU on where they are best, handling data traffic. The unique architecture by using controller-based architecture is that the AP can be on whatever network you want, whatever IP address you want on the access point, because all the traffic is being tunneled back to the controller and terminated there. If we think about this in a simplified way, you can basically think about your Ethernet network, just switching layer 2, layer 3 network as an extended network for your, it's almost like extending the antenna away from the controller. So you're distributing lots of antennas out there, and where the user is does not matter on which AP it is, because the traffic is always terminated on the controller. When you are creating a new VLAN, you don't need to create those VLAN on the switches. The only place you're creating them is on your mobility controller. This simplifies the management a lot. Another thing is you have the ability to create clusters with the mobility controllers. They will enable live upgrade, seamless failover, and so on. So if you look at this scenario where I have a guest and an employee connected to this AP, those devices will not be able to route on your switch. Your switch might have one VLAN, that's the management VLAN only. The only traffic being forwarded is the traffic going to the mobility controller. Another key element with this is your traffic, your employee traffic, is not being decrypted by the AP. The traffic is encrypted all the way from your laptop to your mobility controller in a safe data center. This is a major argument for security, especially in federal buildings or for organizations that have high requirements for security. If you now look in a scenario where a user or these two users are moving, the traffic will still be terminated on the mobility controller and not by the AP itself. The AP is just forwarding the packages. Another key element with this is that the client don't need to do a renegotiation of an encryption tunnel like they would do on an instant. The encryption tunnel is happening between the client, the laptop and directly to the mobility controller without having any changes in it. So there's no rekeying needed. That makes the roaming way smoother and way better for the end user than it would be on a controller-less architecture. So where are we starting with Central and Cloud? Central and Cloud can support both IP8 and AOS 10. So let's start with the basic solution with IP version 8. So like I mentioned, we have our instant access point running with AOS version 8. And that has to be a two-tier LAN design. Your VLAN has to be available on your switches. Just like when we had a standalone IP8 using the virtual controller as the management point, right now the change is that we're managing everything from the cloud, but still the network is exactly the same. It's a two-tier network. We can have up to 128 AP per cluster. We're using the virtual controller as the radius proxy. All of that is the same, but we are managing this from the cloud. The one thing we are enhancing now is we are moving air group to the cloud, and we're adding AI in the cloud. Examples of that would be, how are users doing? What is the client health in the network? Where are clients having issues? How can we enhance performance of these things? Those things are added as a benefit when you're moving to the cloud. We can then enhance this to the next level by upgrading these access points to version 10. What we're doing now, we are not running a virtual controller on the access point anymore. The virtual controller or the control plane functionality is moved to the cloud and fully functional in the cloud. Each AP will work independent and do their own radius request. So one of the key things we have to change is to change your radius server to accept authentication from the VLAN where all the management IP addresses for your APs resist. We are now scalable up to 500 APs instead of 128 and 5,000 users. So that's a big scale enhancement. And we have built a layer for how we can extend even further by adding a gateway to this, which I will be coming back to in a second. So now you see we have added all the benefits of cloud, and we're adding even more by adding more scalability of our access points. And certainly we are running with the latest in architecture from Aruba. If you're growing even further, we can then move to the next level and add a gateway. In iOS 10, you can combine your tier 2 architecture and your 3-tier LAN design as well. So you might actually choose to have one SSID that are bridged locally like we did in the previous slide. By doing that, we are bridging, we call it contractor, it's being bridged to the local switch and flows through the network based on the routing that you have in your network. And then you're adding employee, you want to tunnel employee back to a gateway. Then you're doing forwarding mode tunneling and choosing where to forward that. And you might have another SSID that goes to VXLAN if you want, based on what was covered by Clarence earlier. So now we have added scalability to go way higher than we just had with the 500 APs, because now we can combine that and grow even further. If you're choosing to run with a controller and doing an overlay network back to the controller, then we are centralizing the radius again in our standalone controller or in a controller cluster. We are also enabling the functionality and the ability to have user-based access and have role-based access in the cluster. One of the things that Clarence talked about was the dynamic segmentation and the ability to forward traffic based on authentication and do colorless ports to send that back to the gateway. When you're combining these things in the central account, you will actually be able to create one user role, call that role camera for surveillance cameras. Either that camera is connected using a wire or wireless. As long as they have the same role, they will end up on the same AOS cluster and they will end up being treated with exactly the same firewall policy. So by doing these things, we are simplifying our network design and make it way easier for you to manage your network after it has been installed. When you think about scalability for gateways, if you want to have redundancy, you should go with more than one gateway. I recommend to go with 2 or 3 gateways. By going with 3 gateways, you have redundancy even in the middle of an upgrade process. And with the live upgrade, we have the ability to start an upgrade that is happening seamless for the users. So you can even be on a call, either you're using Skype or Zoom or other third-party applications. You can be on calls while the network is being upgraded. For those of you that are IT admins who don't want to start doing your upgrade during lunch instead of having to do that at 9 p.m. on Sunday night. That's a major difference in how you're operating your network. This is something I call the dream for an IT admin. I will come back to a couple of more things like multi-zone mixed mode in the next slide. So a couple of things on when to add our gateway. Like I said, we can mix these things. So if you need more than 5,000 clients, more than 500 APs on one campus, then you should add gateways for sure. Then we have a couple of other requirements like security. If the client required to have security, or if you need this, security and tunnel the traffic back to your data center, then you should add an overlay architecture and use a gateway. If you're implementing user-based tunneling or dynamic segmentation, you should for sure add your gateway and use that for all of it, for simplicity of your network architecture. I also mentioned dynamic radius proxy. That's a key element to this. You don't need to add the whole VLAN where all your APs are located. You're just adding the gateway as your radius proxy. That is forwarding the request to your ClearPass or radius server. So you only need to add 1 or 2 radius devices to your radius server. That's another simplicity of your network. Then we add something we call multi-zone. Multi-zone is the ability to choose which traffic goes where. Like I mentioned in the previous slide, we might have some clients going to, like the camera, going to one cluster. That might be in a cluster in a data center managed by the facilities or managed by the security department of the company. You might have other users, being the employee users, going to a cluster in a data center where you have all your IT operations equipment. Or you might have guest access going to a data center located in your external data center or in a DMZ zone. All of these things shows that we have multi-zone, so you can send different traffic to different clusters. In a way, similar to what we did with multi-zone on iOS 8 with mobility controller. One of the key things we have changed now is the ability to do something we call mixed mode. That means that when a device is connecting, that might be you're connecting to all of them being an SSID called corporate. You're connecting your employee laptop to that, the company-owned laptop, and that's being authenticated as a trusted device with a trusted user. They will go on the normal IT cluster. Then you have the same employee is bringing up his or her mobile device or a tablet. It's a personal device, and log in with the user's own credentials. Since this device don't have a certificate, this should actually be connected to a DMZ and just get internet access. So then we are based on authentication level, we will create a tunnel for this user to a cluster in a DMZ, the same cluster we're using for guest access. So here we are using the radius authentication and the role access to distinguish which cluster the user traffic should be connected to, which is a really cool feature and extremely flexible for everyone. The next thing we have is to use microbranch. Microbranch is our architecture for using an access point that you can use at home, and your access point is connecting back to the corporate using via a VPN concentrator. Those access points will give you the ability to have your corporate SSID at home and securely connect back to the enterprise just like you're in the office. We can also combine this with the VPN-C and use the Aruba VIA client for VPN software. All of this is requiring gateway in different kind of architecture and different kind of network designs. The next thing, we're also adding SD-WAN into the same dashboard. So you're including and integrating all of these things in one central management plane on Aruba Central. We're going to look a little bit at RF environment and channel planning. This is a pretty old slide showing what are the challenges by having code channel interference. And to simplify this, we're showing this based on 2.4 gig, where we only have 3 channels to pick from. Channel 1, channel 6, and channel 11. If you look at these different APs with different colors, we will see that by using these 3 APs, they will, in an optimal scenario, not interrupt each other that much. So the AP we have in the upper left corner, the AP will not interfere with the next one using the same channel and the same one over here. But when you are in most scenarios, what we are experiencing is that when you're using 5 GHz and the density we're doing with APs, these AP are standing closer than this plan is showing us. So to be able to make this optimal, there are a couple of things we need to do. We need to lower the power level of our 2.4 gig access points. We can also, we should enable or disable access 2.4 gig radios on some of the APs because density and the reach of 2.4 gig is longer than we have on 5 gig and in the future 6 gig. I will come back to that in a bit. So if you're looking at 5 gig, we have way more channels to choose from. We can see in here with the 40 MHz channel bandwidth that most enterprises are using because of the higher bandwidth. Just as a reference, when we're doing 2.4 gig, they're using 20 MHz channel bandwidth. And with 40 MHz channel bandwidth, you're getting at least twice the speed per client. If you're looking at the channels we have in the Uni 1 band and the Uni 3 band, that's only giving us 4 40 MHz channels to use simultaneously. But to extend this, we would like to use also the DFS channels. The DFS channels are giving us some challenges. So the rules are, if there are any radar detection on a DFS channel, you have to turn off that radio transmitter. If you go back 5, 6, 7 years, most customers would not use DFS channels. But later years, we have been experiencing that DFS channels are really reliable. And even when you're close to an airport, there are very few times you will actually have radar interrupt in the DFS channels. The normal radars they're using for planes are not interfering with DFS channels. So there's primarily only Doppler radars for use for weather that are interfering with this. So even when we've been running events in Las Vegas, we are pretty close to an airport, we don't have any issues with DFS channels and that DFS channels are being shut down at all. So I recommend every one of you to use the DFS channels as well because that gives you a lot more channels to use. The next thing that we have ahead of us is Wi-Fi 6E. This new band is using 6 GHz as well, and that gives you way more channels. We don't have any APs out with 6E yet, but that's next generation from both Aruba and all the other vendors in the market as well. If you look here to compare the 2.4 gig, let's start with that. You can see that with 2.4 gig, we only have 1 40 MHz channel or 3 20 MHz channels. If you go into 5 gig, we have 12 channels on 40 MHz that we can use, including DFS. But if you're looking at what we have on 6 GHz, we have 29 channels using 40 MHz, or we can go to 14 channels on 80 MHz, which will give way higher performance. So here you might consider to run with 80 MHz channel bandwidth and get way higher speed for every single of your user, and also you don't have to rely on, you don't have to be concerned about interference from radar or performance that will be dropping if you have to remove array because of radar interference. This is the future, so what we can look forward to is the combination of using all of these bands. So we will be using 2.4, we will be using 5 GHz, and we will be using 6 GHz all at the same time. The performance for the end user will be way better speed and even way better reliability on your wireless network. So a couple of things when we're thinking about Wi-Fi 6, and this is not just because you're going to buy Wi-Fi 6 today, but when you're doing cabling, think about this when you are planning your network. With Wi-Fi 6, it's a higher frequency, means the range the AP is reaching is slightly less than the Wi-Fi 5 and 5 GHz. So on Wi-Fi 5 and previous, we recommend to have negative 65 dBm as the roaming threshold between two different APs. With Wi-Fi 6, because of the higher speed, we recommend to have negative 55 dBm as your roaming point. So that should be used when you're doing channel planning for your network. That means you need more access point, but it will also give you way higher speed. When you're getting APs with that high density, you need to turn off some of the 2.4 gig radios to avoid the co-channel interference. Another thing to think of is to place APs where the users are. So in the cafeteria or in the meeting rooms, don't think about that you want to place the APs in the hallway to cover the meeting rooms, but you should actually place the AP in the meeting room where the users will be. One of the software features we have is Aruba AirMatch. Aruba AirMatch is the technology that's looking at what channels are in use, how much interference do we have, and what transmit power should we have, and which channel should we use, and which channel width should we use for each and every single one of your APs. The AI architecture of Aruba Central is calculating this based on what it knows from similar customer sizes, and have been looking at what are the performance of other customers with similar sizes to you. Central will have this as a baseline, and when it's looking at the performance at your campus, you can look at compare and know that with this kind of signal strength, this kind of channel overlap, this kind of channel width, we will get better performance. And we'll actually optimize the performance in your area based on what I've learned from all other customers that we have. This is also being used as a part of our key management service. So that means when the user is roaming, if you are not using a gateway, the clients when they need to roam, we have to use key management services between the access point. Based on the neighboring APs and signal strength, we know exactly which APs to share the keys with. Another thing is, when you're doing a live upgrade, the AirMatch application need to run in the backend, figure out which APs should be upgraded at what time. Based on the neighboring APs, based on which channels they are on, it calculates that and creating an upgrade plan to make sure that the interference is as low as possible and the upgrade experience for the user is as smooth as possible. Based on all these data being mixed together, AirMatch in Central is optimizing this and giving the user close to optimal performance always. We are recommending to leave the settings and the thresholds for AirMatch as balanced as possible and use the default. The default is based on Aruba's testing in several scenarios, including stadium settings and large enterprises, large universities, and under its very specific scenarios, you'll be better off with the default value. Another Aruba patented technology is Aruba Client Match. What Client Match is doing whatever it can to help you optimize the roam for users. One of the things might be a device that is sticky, and we are experiencing a lot of clients that are sticky. Especially clients with older drivers have a tendency to not wanting to roam. Remember, these devices, like your mobile devices, either whatever brand you're using, they are designed primarily to work optimal in your home. When these are being developed, they are testing them to stay connected to your access point as long as possible. When you're bringing these devices into an enterprise, we don't want them to stick to one access point as long as possible. We want them to always pick the best possible access point. That might be that you have moved into the cafeteria or into a meeting room and it's not the optimal access point anymore because there's one access point with lower load or closer to you. What we are doing there, we are modifying the frames, the management frames going between the access point and the client to tease the client to move to a better AP. When we are doing this, the client will think that this AP is overloaded and it will move to another AP, giving better performance and less latency, and the user will have better Wi-Fi experience. Another thing might be some clients that are sticky to 2.4 gig, especially some older clients that prefer 2.4 gig over 5 gig. What we're doing there, we are trying to tease the client to pick 5 gig over 2.4 gig. One of the things that we are often forgetting is the security behind our architecture. A lot of the wireless network designs from other vendors and generic network designs are thinking about the wireless enterprise and the wireless network equipment as a switch in the air only. At Aruba, we've been taking a totally different approach since Aruba was started. Aruba started based on the architecture of making the wireless as a secure architecture in the air. Whatever client you have, we want to isolate those clients away from each other. So in this scenario here, I have a device being used for sale, so a point of sale device, or it might be an enterprise handheld terminal. These devices will authenticate back to your radio server and be returned that this is a point of sale device or enterprise handheld device. Based on the response from the radio server, they'll be placed in a specific user role. When you're placing them in this specific user role, they have their own personal firewall isolating them from other devices on the network. There might be rules tied to use of time of use. There might be rules based on bandwidth limitation. There might also be just firewall policies to block them away from each other. One example might be a camera again. If a camera suddenly starts doing weird things on your network, we will detect that, and we might have a rule saying the camera is only allowed to communicate to your camera network video recorder VLAN. If the camera is suddenly starting doing ping to different networks or trying to do SSH, well, then you might have a camera that's infected by something, and that should block your network, block that camera from the network. If that is happening, you will automatically get warned, and you have the ability to go and fix that. The same thing with voice and data devices. We are isolating all those devices away from each other using role-based access control. It's a key element to make sure that you are isolating this device away from each other and taking advantage of the security architecture. When you're doing this, you will have a way better security on your network, and you will have a network that is easier to manage. Another thing is, if you have gateways, implement with dynamic segmentation to your switches. And I also recommend that you're using 802.1x for your APs. Let the AP authenticate themselves to the switch. By doing that, when the AP is getting authenticated on your switch, they'll automatically be placed in a user role on your switch for bridging, or placed in the correct VLAN on your switch. Configure your network either using cloud or using gateways or APs locally. Use secure login to your devices. Make sure you're using TACACS or radius authentication of the users to make sure that only trusted users can log into your network. For the client devices, I recommend using WPA3 Enterprise. WPA3 Enterprise is backward compatible with most WPA2 clients. And for guest network, I totally recommend using WPA3 Enhanced Open. WPA3 Enhanced Open will make sure that your guest network are encrypted per individual device, and make sure that the two different clients on a guest network cannot look at each other's personal traffic. The last thing I want to mention with this is enable Passpoint for your guests. If you enable Passpoint, it will enhance the user experience for the users, which means it's way less traffic and need for support to connect users to your guest network. I've given you a couple of ideas on what to think about for your network design. One of the things you can do besides this is check out our Aruba validated design guides. They are going more into depth on what we are recommending based on your radius configuration, based on your network design, based on what Clarence talked about earlier. And all of this will be covered in a pretty good document covering 90% of the scenarios, I think. We're getting towards the end, and one key thing is to make sure you are hitting the Airheads community. Our Airheads community is thriving. We have lots of users using it. We are at more than 120,000 users registered to the Airheads community. There are a lot of questions being asked and a lot of questions being answered by either Aruba employees or customer as well. And please give us your feedback. So in the app, make sure you're checking out the community and make sure you're giving us feedback on what you think about our presentation. And I hope you have enjoyed all of it and give us the best score. And besides that, you should also try out to, if you have any questions, try to reach out to the presenters using the chat function, and we'll do whatever we can to answer your questions. Thank you for taking time and listen to us.